Moving on to the final part for this portion of the assembly is the worm shaft, and I've modified it here since the last time I showed it. I'm using 7/8 stock, and it will have a lip to push against rather than use stop collars everywhere. So this lip will push against the one side, this will push against the end of the worm, which will stick out around it, and then this shaft I'll have a stop collar here, and that'll be all that we need. The only stock I had in 7/8 or anything even close was this stainless steel, this 303 stainless, so I'm going to make it out of that. This doesn't require any strength, so I think that should be fine. So that's what we're going to do. Another note, after making the last part, I tightened this quite a bit because I was having it slop around, and found out that you got to be very careful about over tightening this, because you can easily make it too tight to easily unloosen, which I did, or to loosen rather. So anyways, we're going to set our depth here, and we're going to work on the part from two different sides. I made sure the length of this is pretty accurate, and then I'm going to do this side referenced off this edge, and this side, all of this stuff referenced off this edge, and we'll see how it comes out. All right, so we're going to take 2.316. It's really weird, these odd sizes I chose. I should have laid this out better. If I was going to do a final drawing, after I prove all these things work, I definitely would change these to even values, because there's no particular reason for them to be such strange sizes. They just ended up that way when I moved things around in CAD over and over, and that's how really where we ended up where we are. So we're just going to take off some material. I'm going to take all of this down to 5/8 first, and then we'll take the end down to 1/2 inch. Bumping the feed rate up. This is high speed, roughly 1120 RPM, 2.2 thousandths of revolution. So slow feed rate, high RPM, and I'm getting a much, much better finish. Again with the emery, I'm about a 1/2 thousandth over. So with sanding, I actually took it down a little bit more than I intended, although it's a really good snug fit right now, which is good. These are the bronze oil-light bushings, sleeves, I guess, not bushings, but they're actually still a little tight, which is funny because this is 1/2 thousandth under 625. So, and I don't have a burr on the edge here. So this is I have 2 of these spares, and some are looser than the others, because this one doesn't flop around, but it's very smooth. The other one here is, it goes on, but it's kind of snug, which is kind of interesting. Maybe it's a little bit out around, I'm not sure. The rub marks actually, no, it's actually rubbing all the way around. So yeah, it's just slightly different diameters. All right, so let's go and do the 1/2 inch portion. All right, so here's the fit. It's a good fit. And it ended up loosening up a tiny bit, which is really, cutting off a little bit more in the last pass. It's supposed to only take off, like 1/1000th over, and it still ended up being a couple under. Somehow I screwed up, but it's not so loose that it's going to be a problem. This is just a handle and a wheel, so that shouldn't be any problem. So now we can take this part out, flip it over, and do the other side. Got a live center here, and we got enough stick out to cover the part. We need a total of 5.493, and so we got to take off a fair amount of material. I got the feed rate way up, so I'm going to try 30 thousandths depth of cut See how that works out. I got the feet at 9 thousandths of revolution, and I've got the speed way up. Oh, that's nice. Not quite breaking chips, but we'll get through this today. So I misread my own drawing, and that's the worm. It's supposed to be 0.625, and I brought it all the way down to 0.5. After I screwed up this part, because this is supposed to be 5/8 inch diameter, not half. Everything else is pretty good. We're going to remake it. And I'm trying this tool instead, and this tool is doing fantastic so far with the stainless. A much better surface finish, even with a high feed rate. So I'm kind of impressed with that. And the chips are breaking better. They're making much tighter curly cues than the other ones. Kind of nice. I know I'd be better off if I had a tool with a chip breaker on it that was specifically designed for stainless, but I don't think I have that, so I'm using what I've got. Much better surface finish than the other inserts given me, and it's breaking chips. The bottom port for the handle, which is slightly over, it still needs to have a hole drilled in it. Oh, yeah. Much better fit than last time. Okay. Yeah, no wiggling. I like that. So, there's the handle. All right, let's flip this around, do the other side. It's a 50 thousandths depth of cut, and something like 7 thousandths of revolution feed rate. Beautiful surface finish. The test fit. Really good fit. Still have to put a keyway down here for the worm. And we just now need to finish this end part here. Take it down to 0.375. We're only going in half an inch. This should be very quick. Oh yeah, no wiggle. Right on the money, very good. Alrighty, so we just need the keyway and we're done. One thing I forgot to do that I intended to do was reduce some of the material on the shaft. It's kind of heavy, and I just used these shoulders to press against. So this presses against the outside sleeve bearing, and this one presses against the gear on the other side. But I don't need all this extra material in the middle, and I just thought it'd be fun to try and take it down in size. So we're going to take the inside diameter down to be this, but we'll leave a little material on either side. Alright, that was all for aesthetics, so time spent just to make it look nicer, plus take a little weight off of it. I thought it looked kind of clunky the way it was before. So there's the modified shaft. We need to put a keyway in here, and if I'd left this material on, it would have given me something to grab onto the keyway, but I think I got plenty of material sticking over here. Alright, so I used some zigzag paper to get my Z depth. And we're going to go ultimately 95 thousandths deep, and we're going to do a 1.375 slot, 3/16 diameter, and I've got my RPMs up to 2200. And let's see how we can plunge here. There's a test key in place. It's a small, I just made it slightly less tight by sanding down the sides of the edge on a surface plate with some sandpaper. And I think it's sticking up too much for this gear, so I gotta go look up the specs on the gear and find out what spacing it really wants. To figure out how deep the key's actually going, I take a mic over my test key that's on the bottom and find the high point on the bottom. Take that difference and subtract from the diameter of the shaft, which is 0.0625 or 0.624 right here actually, and we should be good to go. Here's with the gear in place, and you can see the key in there. It's actually nice and snug, so it goes on and just really holds nicely. And then I can slide the collar up against this. It's not going anywhere. It's perfect. Sorry, so on this side we drill for the handle that rotates this whole mechanism. All right, so it's time to attach the hand wheel to the shaft. I've got a couple interesting things relating to this. So first, my weird setup. So the vise is here, simply clamped to the wheel and just sitting on the mill table to prevent the hand wheel from rotating. And I've got a stop collar in here forcing the hand wheel back up against the lip so that it can't go in, so it's right on position where I want it. I've got a little extra shaft sticking out here in case I need to make some changes in the future, but that's another thing. I've also marked the hand wheel with a little line here showing dead vertical with the hole I'm about to drill here. Now the hole was going to originally just be for a standard pin, but I thought I'd try something unusual. So I took this quarter 20 Allen head bolt and I turned the bottom of it so that it is a 3/16 pin with the top still having threads. So what I'm going to do with this is I'm going to drill all the way through for 3/16 and ream for 3/16, and then I'm going to tap the top part of the hand wheel so that it will hold the pin in place. That way it's easy to remove this pin in the future at some point. Now to make this part was kind of interesting. I came up with a quick little tool to do this, so I just cut off a piece of material here that was long enough to support the screw. And what I did was, first I faced it, drilled and tapped this side. Then I flipped it around, bored it out to the thickness between here and where the bolt would sit inside so that it would be the length of threads I was interested in. And then to prevent it from backing out, I threaded and tapped for 1/2" 13 the whole inside of this guy to push against this. Also, when I was trying to drill the end here with a center drill so that I could use my live center, I threaded this screw in just part way, leaving just a little bit exposed to support it, and then I put this 1/2" thread and pushed up against these other threads here, which forced it to stay in place, which was great because all this was threaded originally. So that forced it so it couldn't back off while I was trying to center drill it. So I center drilled it, tightened this guy all the way up to here, which is the flat spot in there, if you can see it, and then put the 1/2" 13 bolt behind it, held this in my 6-jaw chuck, made a useful tool really quickly. It was quick to make and it worked out better than I thought. Now, I do have a concern that even though there's an alloy screw or bolt, that this won't be strong enough, but I don't think there's that much force going on here. So we're just going to try this. If it doesn't work, I can always rotate 90 degrees and re-drill with a 3/16, and that's what I'll attempt if that works out. But I don't think that's going to be a problem, so we're going to just try it. First up, we're going to center drill. And I know you don't have a good angle to see there. That is a lot of run out. I'm going to have to figure out what's causing that. There it is with the pin assembled. It was kind of snug, so I had to tap it in before the threads would engage, and this is just aluminum. So I had to give it a little tap to get the thread started, then it pulled right in, and it's a wonderful fit, so I'm very pleased with that. That turned out good. So, except I'm going to need to take that off in order to put this thing together, so I'm going to tap that out. All right, so here it is apart again, because this has to slide into a sleeve, a bronze bushing, and then this part gets put on the outside. And I did cut a little bit deeper with the one drill bit, although it's not affecting it any. Fortunately, that was stupid. I should have just taken this out and drilled this manually. So you can see the small hole on one side and the threaded hole on the other side. And this guy, you end up having to tap it through. It's nice and snug, so it's great. And then you can see it mates nice and flush. So it's a perfect deal. And actually, it's kind of good that the threads were a little bit long. So it's kind of good actually that I screwed up, because then the threads can go a little bit into the center shaft. And it'll still hold, so all good on this one.